Sometimes in science, it can be challenging to draw direct links between research and the real world. And it's no different in crash testing. Regardless of how advanced and specialized a dummy is, it can't match the complexity of a human body. So we have to be very careful when we look at what dummies tell us in crash tests and how that might translate into what we would expect to see in the real world. It isn't always straightforward. To learn a little more, Linda and Griff have a few questions for me.
So I'd like to talk a little bit about some of the things we might hear in the media and misconceptions people have about the way science works. So I'd like to specifically talk about the difference between a coincidence, correlation, and causation. So let's use an example that's related to crash test dummies. So is it true that more male crash test dummies have been used in crash test research than female dummies?
So at IIHS, we use a combination of males and females in our ratings programs. But it is true in our frontal crash tests, we use the male dummy in the front seat.
Is it true that in general, females are at greater risk of severe injury in a vehicle crash?
That is true. Women are at increased risk of serious injury in crashes.
So is that just a coincidence? Those are just two true statements, but they're not necessarily connected to each other, or are they correlated to each other?
So that is a coincidence. The fact that we use male crash test dummies in our frontal test programs is not the reason that women are at increased risk of serious injury in crashes.
Okay, so they're not correlated, and if they're not correlated, then you can't say one causes the other. So what about claims where people might say, well, the reason that women are at greater risk of serious injury in a vehicle crash is because they're using male dummies in the crash tests?
I can see how that would make sense to people. That does seem like there would be a causal link there. But we have to remember, when we are doing crash testing with a dummy, whether we call it a male or a female, it's really just a tool where we're able to take some measurements and then translate those into a potential injury risk. And when we go back and look at the real world data, what we see is that the improvements in vehicles, things like the crumple zones, improvements to seatbelts and airbags, are doing a really good job protecting both men and women. Historically, the data have shown that women are at increased risk of serious injuries compared with men, but there are some reasons for that. For example, they're more likely to be in the struck vehicle in a rear impact crash or in a side impact crash. And those types of crashes, and whether you're in the struck or striking vehicle, can have an effect on your injury risk.
If you're in the struck vehicle, typically you're going at a lower speed than the car that is striking you. And typically that means you're going to absorb more of that energy.
And if you think about being in the struck vehicle in a side impact, we don't have those crumple zones, and that's a very vulnerable crash mode to be in.
And you're going to have more injury risk because of that.
Exactly, and that brings up another important point, that women tend to be in smaller, lighter vehicles than men.
Right, that's the physics too.
Exactly. So when we look at why women are at increased risk of serious injuries, some of that is because they're in different types of crashes and they're driving different types of vehicles, and so their exposure to those crash risks are different. But what we do know is that in more recent model year vehicles with the newest safety features, with the newest seatbelts and airbags, that difference in injury risk has essentially gone to zero for those life-threatening injuries to the head and torso. Where we do continue to see a difference in injury risk between men and women is in less severe injuries, things like broken bones, particularly to the extremities, the arms and legs. We need to understand what's happening, what are those differences, why are they happening? That's something that we're still researching. And once we figure out those pieces, then we can incorporate it into our testing program to incentivize improvements to vehicles that will reduce the likelihood of those injuries.
So maybe that will be another modification in the next generation of crash test dummies.
It may be, but it's a much more complicated question than whether we're testing with a female crash test dummy.
So what's interesting is I think human nature, we love answers and we like nice, neat packages. But it sounds like the male crash test dummy being used in frontal crashes and the female likelihood of severe injury, we would love to connect those dots, but it doesn't sound like there's any connection at all.
No. Putting a female crash test dummy in the front seat, it's not going to hurt anything, but it's also not going to drive the improvements that are going to have an effect in the real world. That's what the data show us.